So in this question, we want to calculate what's the normal force and what's the force F1 on this diagram, given that we've got the angle theta here. And then later we're going to calculate with these examples. So what's the normal force? How are we going to calculate that? What's this force and force F1? Well, this force here, it's the component where this box, x kilos, is sliding down. So what force is that box sliding down at? Now we've got, with this diagram, we've got the gravitational force, which will be the mass of the box times the gravitational constant, which is going to be x times g. Now g is normally given as 9.8. It can be given as 10 sometimes, but it will tell you what it is, and that's what you can use when you're trying to work out these questions. So we want to calculate what's the normal force in F1. So what we need to do is we need to draw our forces acted upon this perpendicular or parallel to both of these lines. So what we need to do is draw a little triangle along here. That's what we need to do. So if we do that, we end up with a right angled triangle, and then we've got a line here and a line here, which are parallel and perpendicular respectively to our two different forces. So this one along the bottom of the triangle will be F1, and this one here will be N. That'll be the normal force. Now the reason that force there will be equal to the normal force is because, for example, if this is in equilibrium in this direction and it's sliding down, this force acting on here will be the same as acting on the force in this direction. So they will be the same. So how are we going to calculate what that is? Well, here we use trigonometry. So we use our SOHCAHTOA. So let's use that. So SOHCAHTOA, sine of an angle theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse, and tangent theta equals opposite over adjacent. Now we've got the angle here theta, but we haven't worked out what the angles are inside of here yet. So let's just draw a slightly bigger version on the board here. So let's just copy this triangle there. So we've got a right angle and a line going straight down. Now that's our normal, and that's our force 1. This one here we know is equivalent to xg, so the mass of the box times the gravitational constant. So that there is xg. Now this angle here is theta, which goes along in a straight line. So let's do that. So we can now, so imagine we've gone on in a straight line here, and then we've got our angles theta. Now let's just draw that on here best we can. So let's just pencil that in there. That will then be a right angle triangle again, and this angle here will be theta. So with a right angle triangle, if this is theta, this angle is going to be 90 minus theta. So if this angle is a right angle and this is a right angle, when I've drawn my picture, I've then got this angle here is also a right angle. So therefore this angle at the top here will also be theta. Then of course I could write this one in as 90 minus theta, but I don't need to at this stage because I just need to work out what theta is. So now using the laws of SOHCAHTOA, I can work out what my N and my F are by using these rules here. So if I say sine theta, that equals opposite over hypotenuse. So sine of theta equals opposite, so that's F, and the hypotenuse is this one here, opposite the right angle, is xg. So F over xg. Now to get F on its own, I've now just multiplied both sides by xg. I've got xg sine theta. So that's my force F. Now if I use cosine of theta, that's adjacent over hypotenuse. I've got the force N, and the hypotenuse again is xg. So therefore, if I want to isolate the n, multiply both sides again by xg, and then I've got my force n, my normal force is xg cosine of theta. Now tangent theta is opposite over adjacent. So tangent theta is opposite over adjacent. So let's write that one in here. I'm just going to put this one up here. Tangent theta equals opposite over adjacent, which is n over f. Sorry, f over n. So then I can isolate accordingly by multiplying both sides by whichever one I prefer. Okay, right. So now I've got some questions here. Find n and f1. So normal force and f1 if sine theta equals 3/5. So here, let's go into here. So part 1. Sine theta equals 3/5. So therefore my force equals xg. Sine theta is 3/5. So that's 3/5 xg. So 3xg over 5 basically. Now what's the normal force in this diagram? Well, I don't know too much about cosine theta just yet, but what I could do is I could draw a right angled triangle. So just draw a sample of a right angled triangle, and I know that sine theta is 3/5. Sine theta is opposite over hypotenuse. So if this is my angle theta, sine theta is opposite over hypotenuse, and that's 3/5. Now by using Pythagoras, I know 25, 5 squared is 25, 3 squared is 9, 25 minus 9 is 16, so that's going to give me an angle 4. And that's a Pythagorean triple. So therefore I know cosine theta is going to be adjacent over hypotenuse, so that's going to be 4/5. So there in part 1, my normal force is xg times 4/5. So that's how I can work that one out. Now what about part 2? I'm given cosine theta. So let's work with this one first, because that's one with cosine theta in it. So it's 24 over 25. So n equals xg 24 over 25. So that's pretty straightforward. But I don't know too much about sine theta just yet. So let's draw another triangle. This time I know cosine theta is 24 over 25, adjacent over hypotenuse. So hypotenuse will be the 25, adjacent will be the 24. So to calculate this one, I've got square root of 25 squared minus 24 squared, and it's the goes inside there, so minus 24 squared. So now I've got the square root, 625 minus 576, which breaks down to square root of 49. So this side here is 7. So I know sine theta, opposite over hypotenuse, that's 7 over 25. So F equals xg times 7 over 25. That's my force F, or F1 as I've marked it as in the diagram. Now part 3, tangent theta equals 5/12. Again, tangent theta, but I don't know nothing about sine theta or cosine theta. So let's draw another triangle. So tangent is opposite over adjacent. Opposite over adjacent. So 12 is the adjacent, 5 is the opposite. So if I want to work out this side, I've then got a squared equals b squared plus c squared. So therefore a squared equals 5 squared plus 12 squared. 144 plus 25, that's 169. Square root of 169 is 13. So therefore this side is 13. So now I can now calculate, because I now can work out what my sine theta and cosine theta are for part 3. So my force F, xg sine theta. So F, xg sine of theta. sine of this angle, opposite over hypotenuse. So that's 5/13. These are all exact values, so I've not calculated these on the calculator. These are all the exact values. So now my normal force is going to be using cosine theta. That's adjacent over hypotenuse. Adjacent over hypotenuse, 12/13. So xg 12/13. So that's my normal forces and my forces with these calculations. Okay.